Hi, my name is Mark Evenson, and we are here to do a panel with representatives of implementations of Common Lisp. So we have, I hope the ordering is the same on all browsers, but on the upper left-hand corner of my screen, we have Kevin Layer from Allegro, Franz Lisp. We have Christopher Rhodes from SBCL. We have Christian Schaffmeister from CLASP, and we have Daniel Kosminski from ECL. And I happen to be a maintainer for ABCL as well. So just like to start with a round of introductions going around in the order that I introduced you. Just take a minute to say who you are and what you're working on. And yeah, thank you. So first, Kevin.
Greetings. So I'm Kevin Layer. I work at Franz, one of the founders, 1984 to now. It's been a long Common Lisp ride. Franz still does sell Common Lisps. We also do Allegrograph, which is a graph database. And that's been a big focus of ours for the last 12, 13 years. It is implemented in Common Lisp, and that's about it. Thanks.
Okay, Christoph.
Hi, I'm Christoph Rhodes. I work for Google, and it's probably worth saying right now that nothing that I say should be taken as anything to do with anything that Google thinks, says, does, or believes. Apart from that, I've been in the Lisp world for not quite 20 years. I think my first commit to SBCL can now vote in most jurisdictions, although maybe not drink.
Okay. Christian Schaffmeister, please.
So yes, so I've been in Common Lisp for about 6-7 years. We've implemented a Common Lisp called CLASP, which we are using as a basis of a scientific programming environment, mostly for computational chemistry, called CANDO. The distinguishing features of CLASP are that it uses LLVM as the back end, and it interoperates with C++, so it's easy to integrate C++ libraries into it.
Thank you. Daniel?
I'm Daniel Kosminski. I'm maintaining embeddable Common Lisp as a commentator. I'm contributing to Common Lisp because I'm like for 10 years, maybe a little less. I'm also one of core contributors to MacClim, so I'm mostly orbiting around free software, but I'm also working on commercial gigs because I'm running my own Common Lisp company, Tartular, and I think that regarding ECL, it is one of three Common Lisp implementations which targets C language runtime, so it may be embedded as a shared library in bigger C applications.
Thank you. And to reiterate, I'm Mark Evenson, and I'm with ArmBear Common Lisp, which is distinguished as an ANSI Common Lisp implementation that runs purely on the Java virtual machine. And I've been involved in that for about 15 years, and we only became ANSI compliant in 2011. So anyways, I usually like to say that I'm happy to be the dumbest guy in the room because that means I have the most to learn. And on this panel, that certainly is the case. But I'd like to take this time to reflect on the ANSI specification itself and its relationship to what we do every day. So I reviewed Peter Seibel's talk at ILC 2010 in Reno. He made a cost estimate that it took roughly $1 million USD to make ANSI happen as a specification. So I'd submit to the panel that that means that there's not going to be another ANSI specification. And I would ask then, what does that mean for you as someone who's actually steering an implementation? It may mean nothing. Maybe you've superseded it and stuff like that. So let's go in reverse order. Daniel?
Okay, so ECL is quite less popular than SBCL or Lispworks. So when we want to implement extension, we just go like the shopping mall and see what SBCL implemented and implement it in ECL. So that's basically the strategy, unless we have something good in mind. or we have something what we don't have yet, what is important, what would improve performance. But basically, when we want to extend beyond ANSI standard, we try to mimic existing implementations for compatibility, and because there are many smart people.
Thank you. Christian?
Yeah, so I guess what it means to me is that we have used a lot of Common Lisp libraries that, quick Lisp libraries that work. They simply work. And so we appreciate that the core of the language is powerful enough and well specified enough that you can have all this software that sometimes it hasn't been maintained. There've been no updates to the like the GitHub repository for years, but the software just works. So that's something that I like about the having a common ANSI language.
Thank you. Christoph?
So I wasn't there when ANSI was all happening and Common Lisp the language before that. But it seems to me that, clearly the benefits of the standard as it has existed for the community are that we have 20, 30-year-old software that works on actively maintained implementations, because there's a sort of contract not to break. There's a clear, relatively clear yes or no, is your thing compliant, is your thing compatible, is your thing. But my understanding is that some of the motivation back then was user driven. So it was user or funders of users saying, we would like a common basis for things to work. And just because there isn't going to be another ANSI standard, probably, doesn't mean that we don't feel or can't feel user pressure. Pressure from users to say, actually, we would quite like it if, the 6, 7, 8, 9 implementations were more compatible in this way. But that will take, I think that will take pressure from the community of users rather than appearing from, the sky.
Yes, I agree. It'd be interesting what the nature of those pressures could be channeled as for us as a community. So, Kevin, ANSI specification, relevant, not relevant for Franz?
Well, I mean, I think it definitely is very relevant for a lot of the reasons people said. It gives a common basis for people to be able to write code, put it into Quick Lisp, and just sort of to share it and just to sort of not even think about it, right? I mean, years later, it just seems to work. I don't know if anyone here remembers or was even part of the early 2000s. There was an ANSI meeting that tried to sort of revive a second round of changes. I was part of that. It was a little frustrating. The problem was that the original round of ANSI changes was done during a time when there was a lot of Lisp companies and a lot of Lisp implementations. They were well funded, and each implementation had multiple people working on just doing ANSI work. So the $1 million that was, mentioned earlier, that was just sort of one side of the equation. The other side was the money that all the implementations spent. And I don't know exactly, we never tallied up the amount of money Franz spent, but I would guess it was close to that over the years. So I would say that it's many millions of dollars it took to do the original standard. And back then things were quite fragmented, right? I mean, there was a lot of fragmentation. There were people that had programs in one silo that wanted to run them on other implementations, and it was a very different situation than we have now. So what happened in the early 2000s, the reason why I was frustrated by it was that there were really just two implementations there. There was ListWorks and Franz, and the Lispers guy didn't. I don't even remember who it was, but he barely talked the entire several days. And it was just the users kind of doing pie in the sky stuff, like, oh, we'd like this, we'd like that. And there was no understanding of what it would take to do those things. And it frankly was pretty terrifying for me sitting there as an implementer in the early 2000s after, you know, the implosion of a lot of companies. And you know, things were looking pretty bleak from a software standpoint, from a small software company standpoint. So thankfully that effort didn't go anywhere because it really wouldn't have been healthy for anybody. So the question I have is, are future standards efforts really focused on forging new territory, or are they just sort of trying to iron out the differences between implementations? And honestly, we don't really see, you know, our customers or the community that I see having really that much of a problem between, you know, using our Lisp, LispWorks, SBCL, whatever it is. I just don't see that many issues. So my point of view is the ANSI standard is a really good thing. It's there, solid. But I really don't want to see another round of that kind of thing because it's extremely expensive. And honestly, I don't think we have the, you know, the manpower to do all that. It's you know, it's just not there, I don't think. So
I totally agree with that. Or at least we can't even conjure up $1 million of crowdsourced stuff, right? But what is different now between 2 decades ago is that they're actually not too much different. There remain 2 commercial implementations of ANSI Common Lisp, right? That are readily available and supported. But there are 6 or 7 open implementations that are, through QuickLisp, through Zach's work and stuff like that, have actually cooperated and gained a lot by actually standardizing on things, right? And we cooperate on those patches and maintain a level of compatibility of it that is certainly informally specified and policed by a community. I have another softball questions, but this is, does any of the panel have questions in general or comments they'd like to make about what we've spoken about so far?
Well, I would like to add that this compatibility is also part of cooperating between implementers, but a lot of effort is put by people who actually create portability layers, like Bordeaux threads is a library which actually hooks into functionalities of each implementation and provides different implementation for threading for all. And thanks to that, the Common Lisp programmer just can use it and they doesn't care what implementation is underneath, at least for that.
So
there we have a demonstration of users, right? Rather than implementers actually extending the implementation in useful ways.
Right. So I just to riff on that a little bit, was trying to think of where you would really need a standardization process, as opposed to, some interested user or community of users saying, okay, we're going to approximate an interface for whatever it is, threads maybe, and say, okay, we're going to build whatever we can on top of what each implementation affords. And, you know, once you've done that and you've ironed out all the rough edges in it and you've got something that looks good, I mean, you could standardize it, but there's no particular need to because it's there. So I was trying to think of an example where, you know, maybe to contrast with that, where you really can't do that, and also maybe to highlight the, as Kevin was saying, the kind of shivers that the implementers in the room would get into when sort of faced with a user demand. And the example that I came up with just to think about was, well, what if a subset of users said that actually it was really important to them to be able to have a mechanism for inline assembly. And the reason that I see that as much more challenging for a community of implementers, and yet realistic, because, you know, C compilers that you do in inline assembly, I mean, realistic in quotes. The reason that that's much more challenging is that the Lisp implementations run on lots of different architectures. There's no sort of standard for calling conventions or register usage, unlike an ABI.
Mhm.
There are plenty of implementations that don't compile to a direct hardware implementation. So what does it mean for inline assembly in ABCL, for example? I mean, there would be all of these questions that are really hard to get to grips with. But on the other hand, I can imagine some community of users saying, wouldn't it be nice to have a standard way of doing inline assembly? And the conversations might go on there with people like me going, yeah, it might be nice. But there might be something in that space, the beginnings of an inline assembly keyword that says, okay, well, here is the start, now go wild.
Well, class bends over backwards to make a very efficient use of assembly, right? In the C++ that you're calling, right?
We don't actually have any inline assembly, but we do integrate tightly with LLVM. They have an intermediate representation that we use pretty closely. I would like to see. I think inline assembly, that's a real challenge. But things like user extensible sequences, Christopher Rhodes' paper on that. That's a great sort of standard to expand on. I'd really like to see more generic functions being used for in the language. Given that now we have fast ways of implementing them with like Robert Strand's generic function approach.
Daniel? Inline assembly in ECL?
Well, this is basically possible already because ECL allows inline C, and you can inline assembly in C. So you can write C, which inlines assembly. It doesn't sound good, but it would work actually. But regarding this cooperation to implement things, I'm not sure if everyone is aware of it, but there is a mailing list, Common Lisp developers on commonlisp.net, and there was a proposal in 2008 to standardize on the function exit or quit, I don't remember. And it didn't actually happen, and it was just agreeing on the interface how to exit from the implementation. So agreeing on something complex, it's hard, and what is more compelling to actually how to follow is like one implementation has one extension which is pretty popular, and other implementations follow. That's what basically happened with package local nicknames proposed by Nicolas Sivola in SBCL. Then it was implemented in ABCL, I think, then ECL, and then it followed with different implementations.
Yeah. As far as using specifications, there's essentially two historical thrusts that have sort of happened in the last 20 years, right? There's the attempt to take the hyperspec and free him from the bonds of Mickey Mouse copyright and actually make something hypertextual where you could add things on easily. And then there's the effort to actually make systems that work, right? So, and then use there was a CUDR process, and there's also this resurrection of CL-CAR. So it would be a standard RFC-like mechanism by which a document is agreed on by the implementations and ratified, and then implementation status is tracked. And the group tries to cajole implementers into doing that. So maybe we could have a few words about how your implementation has treated CUDR or its successor or stuff like that. So for ABCL, I think we implemented the first 5 or 6, and I think the repository has not really been updated in any meaningful way for 10 or 15 years. Daniel?
ECL has implemented a number of CDRs, and when we have 3 cycles, we want to implement more of them. So this is something what we want to do and we are doing. But if there are just 2 core developers and there are many fronts to improve the implementations, we can't do everything at the same time. So it's going really slowly, but and we are rejecting some of CDRs because we don't consider them as something important or something what we need to have inside the implementation. When we find something as something what we want, then we implement it and just push CDR7 into features or whatever.
Did you find a meaningful mechanism to comment back to the CDR community that the implementation couldn't really support it for some kind of?
I don't think there is some feedback mechanism. At least I didn't find one.
Okay. Christian, what's CLASP's position on CDRs? Know they exist?
I did not know they exist. I just Googled it, and I'm about to look it up.
Okay, well, that's
Fascinating.
a data point. So we have mechanisms that the implementations don't even really know about, right? So, and actually one that I thought would have been well propagandized and so forth. Although, admittedly, it's really been dormant for 10 years, as far as I could say. Christoph, SBCL and CDRs? You're muted.
Kevin.
Yeah, I was going to say that, yeah, I do remember watching that process sort of spawn and work through what it did. It seemed to me a lot like the process in the early 2000s, though, that it was being driven by users and that mostly, and that the process originally went on in the ANSI committee to discuss changes to the language wasn't present, and that it would result in unreliable specifications, in my opinion. I mean, the problem is, and you know, I think the implementers in the room know what I'm talking about when I say this, but other people may not quite understand it. But it's one thing to use a language and to have ideas on how you should change it. It's another to be responsible for the stewardship of the language and sort of moving it forward in a consistent way. And you know, we get suggestions from our users all the time, like, why don't you do this? Why don't you do that? And it's like, well, because we have a lot of users, and that would be a bad thing. You know, it may be good for you, but it's not good for everybody. And so, you know, once you put on the hat of an implementer, your orientation changes in a way that is not obvious to the other side. And it really, it makes things much more difficult to move forward, especially if you're changing existing things, because there are often very hidden ramifications. And if you're adding new things, it's so hard to design an API that is not broken in some way. I mean, it just, you know, I've been doing this for many decades, and it just still kind of amazes me how difficult it is to design something that it will stand the test of even a short amount of time. So it takes a lot of effort. And you know, the coders, I think it's interesting, but I don't think it's being done in the right way that would allow the result to be high quality. That's my opinion, and I hope I didn't offend somebody that was involved in that process.
No problem. Thanks for the honesty. I think we should, you know, say what's useful for us and what's working and what's not working. It's tough.
Yeah, I agree. I think that the point that both Daniel and Kevin said is important, that the lack of a feedback mechanism from implementers to the coder authors, and you know, the ability to finalize a coder before, and you know, multiple implementers or implementations have had a chance to look at it. It's problematic because the you know, part of the fun of being an implementer is in looking at all of those trade-offs that you've got. Because sure, you can do this thing, but then that's going to mean that you can't do that thing, or that the other thing has to be implemented in this really weird and possibly inefficient way. And that's really fun. It's an, you know, fascinating set of constraints. And you know, if you get it right, you've got a lot of happy users, and if you get it wrong, you've got a lot of bug reports and a lot of pain. And then, yeah, sometimes some of those coders, not all of them by any means, but some of them seemed like, well, I've got a problem and I'm going to solve it, and now I'm going to solve it for me, and then it's done. And that's, to me, that's the start of, to me as an implementer, that's the start of the process. And in a sense, it's a shame that there hasn't been a sort of cycle of, oh, okay, CUDA 72 turns out not to work so well in implementation B. Let's make CUDA 157 that supersedes this one, makes it better. But I'm not surprised that doesn't happen. It takes effort. It takes a lot of work. And if the original problem has been solved for the original motivator behind the original CUDA, it's maybe not surprising that it doesn't get future attention.
Yes, agreed. Yeah, a lot of reflections here. I'm not sure if we want to open it up for audience. I have one kind of final softball question from the ghosts of the ANSI specification. But many of them are still alive, and some of them are watching this right now. As an implementation, what's the best thing you did with the implementation, and what's the thing that they would be the most mad at you for? So I guess I could start with ABCL. Well, the best thing is we actually passed these ANSI test suites better than anyone else, and that's been really important in keeping the implementation stable going forward. Perhaps the worst thing we've done in the specification, I don't know, implemented in Java? I don't really understand the answer to my question. But anyways, Daniel?
Well, that's a hard question. I think that a very important thing for me wasn't really Lisp related, because I have fixed makefile, so I can just type make -J9 and it compiles in parallel, but it isn't Lisp. Well, I think that a lot of cleanups things are just add up. I don't think that there is some outstanding thing which we have implemented or outstanding bad thing which would just drown the implementation. It's hard for me to answer actually this question.
Maybe it's not a great question, but okay, let's go around. Christian?
Well, we managed to implement the entire standard with a JIT, just-in-time compilation, using just like standard Unix and LLVM tools. Still, we're using like really cutting-edge stuff. Right now, we're using a version of LLVM that is only about 2 weeks old. So we're still pushing the envelope there. The worst thing, I guess, is just didn't realize how complicated it was, and how rich and how much time it would take to get to ANSI compatibility.
Thank you. Kevin?
I would say the hardest thing was probably getting CLOS to be just right and performant at the same time. That was probably one of the hardest things to do. I mean, the rest of the effort was, I mean, those are probably the most recent things we've dealt with over the last decade. The rest of it is, honestly, it's so far back in my memory, I've mostly forgotten all of that. That was the 90s. So
fair enough.
Yeah.
Thank you.
Too far away.
Fine. Christoph?
All right. So the getting CLOS and the mop into some kind of shape, which I should say is in SBCL's case is quite a lot due to the work that Gerd Müllmann did on CMUCL back in the day. But teasing at all the places where that mop, as described by the book, can be made to work and can be made to work well, and also finding the places where actually it can't and documenting those and saying, here's why we're not doing this. That's pretty cool. I'm also pleased at having written helped to write a Common Lisp implementation in Common Lisp, as opposed to all these other weird implementation languages. Slightly tongue-in-cheek that you may not be able to see. And bad things, there are plenty. Probably the one that, Yeah, maybe being an implementation that still has support for arrays that can't hold anything. That's kind of a bit of a vanity feature, even if my collaborators recently decided that they shouldn't be strings after all. Let's go with that.
That's a great lacuna. Oh, you want to say something, Christian? Go ahead.
Yeah, I'd just like to add something that I didn't have to deal with a lot of the problems that you guys, other people had, because we stole a lot of that code from ECL. So we are built on top of ECL's Common Lisp code and learned a lot from the C code. So there are things that we implemented that I don't understand, but they do reach ANSI compliance because of the work of previous people.
Oh yeah, I actually didn't. I knew the heritage, but actually, it would be a direct descendant, wouldn't it? Very good, very good. And does ECL get anything back from CLASP? Better documentation, making sure it works.
Well, we are exchanging from time to time bug reports, sometimes fixes. So it is really great because there isn't any bad blood between forks. So I think that the implementations are different. I have tried to backport some changes from CLASP, and actually it didn't work for ECL because of different compilation target. And for instance, CLOS was working actually slower on ECL, while these changes made CLASP faster. So that's one of examples. Right. So, and regarding previous questions, what I'm most proud with ECL, this more social thing. When I started contributing to ECL, it didn't have the maintainer. So on IRC, there were a lot of comments like ECL is dead, nobody works on it, and nobody thinks that right now. So I think that this is a very big success for the implementation to just rise from the dead.
Yeah, and if you had stepped in, we wouldn't have CLASP. So thank you.
Well, I think that CLASP was being developed in parallel already, so it has full steam in front of it.
Yeah, we've shared a lot of bug reports back and forth.
Good. Good. Okay, so I'm going to open, unless anyone has in the panel wishes to make some kind of statement, I'm going to just open it up to questions because it looks like we have a lot. Anybody like to talk? Okay. So there's a question from this experiences of an implementation that has to implement a standard. What recommendations you would have for other Lisp family languages when they should consider what sort of mechanism they should adopt and specify their behavior? Anyone have an idea of how to answer?
I would say definitely have something like the ANSI tests, large set of regression tests that you can run.
But you couldn't have the tests without the specification, right?
Right.
Yeah, I think that it would be a really good idea when future standards are put forth that many more examples and tests are submitted along with the changes. I mean, I think everybody here has probably looked at RFCs for various things and just been aghast at like the lack of actual real examples in them. For example, the URI RFCs were very difficult to understand at an implementation level because there were all these holes, and examples could have, been very good at filling those. So I definitely, the older I get, the more when I write APIs, I write tests along with them, because I think it just shakes out so many different things when you try to write something with a new API. So
yeah, tests are definitely you can never write enough, so don't try for full coverage, but some are better than none for sure in my experience. Anyone else like to comment on that?
Yeah, I mean, it's not a substitute, but maybe a slightly different axis. I find it really useful to write down what I think the behavior of a function is, or whatever, because that forces me to think about the what ifs, the the non-happy path, the one where an input is not what I expect it to be, or the state of the world is not, the preconditions are not as I expected them to be. And starting that documentation process, it's not standardization, but I do most of my programming for professional purposes in other languages, and the grinding of my teeth is probably audible all the way from here to my office as I read the documentation and discover that actually it doesn't specify, unlike the CL standard, it doesn't specify what happens in exceptional circumstances. It doesn't specify what happens if the collection is empty, or whatever. All of these things that actually do happen, and without, if it's not written down or it's not in a regression test suite, then the implementer of a language might decide to change it, and that might break my program tomorrow. And that's a very uncomfortable feeling for me to have.
Yeah, certainly. I guess when something breaks in the bear, I go to the hyperspec and I try to understand it. And I gotta say, it took me like 10 years to realize that you have to read all the errata and comments to understand things, that it's not enough just scrutinizing the, so yeah, but there's a lot there. And I find by reading the discussion about the errata, why we didn't do something, to be often more informative than the documentation page for the function. So it's an interesting thing. Anyone else to this topic? We have more questions actually, so it's good. I apologize if I'm slighting someone in the IRC. Jack or Christian, you want to say something about? Okay. Okay, so this is a question from Didier. Opinions on standard evolution as 1, new specifications / additions, versus 2, agreeing on one solution or on underspecified areas. So I guess that's an either or. Standard evolution.
I think that this is a question of whether CADR is better or ASDF. Everybody adopted ASDF, but it wasn't actually specified, standardized, and it is not that everybody likes it very much, but everybody uses it, even if they don't like it. So from practical standpoint, it is actually how things go. First, we adapt things, and then I believe that's what happened with Common Lisp standard, that people were using things, and they have decided to come with some uniform API for everything to work. But it was just things were working as they were working, and they were trying to clean it up, not that they had came up with some particular feature and specified it.
Someone else? On standard evolution, new specifications versus one solution on underspecified areas as being the right way to go. I guess that doesn't. Okay. Next one. What would it take to get implementers to change something fundamental like IEC, IEEE language independent arithmetic? I don't see how why would one, well, okay. The numeric stack is always a little bit questionable to me.
I mean, I'll jump in if you want. I mean, I think that things like this are pretty fundamental, and if it changes existing behavior, it's impossible to do in something like Common Lisp, because you don't want to break tons and tons of programs out there. If the question is about adding something on that doesn't exist, I know that kind of stuff is really hard. I mean, if you're talking about like, floating point and overflows and different types of things like that, I mean, that's really, really, really hard stuff. And most of us are at the mercy of libraries that we use provided by the operating system. And to find libraries that exist across all platforms is sometimes a big challenge. Windows, Mac, and Linux are pretty much the main platforms these days, but there definitely are a lot of other ones. I mean, SBCL runs on a bunch more, and we've run on a bunch more as well in the past. So stuff like that is difficult to do well across all platforms. But I don't know specifically what the question was about in terms of the feature.
Yeah, I guess what it would be to standardize on sort of an IEEE language independent arithmetic, which I don't know if that refers to something beyond just doing floating points like IEEE says you should do. So with some kind of specification.
And that's hard. I mean, even just doing floating point like IEEE says you should is or how users wish that IEEE said you should turns out to be really difficult. I mean, to the extent that we as SBCL implementers are struggling with it. Tiny anecdote if I have time, but it's recent, as in last week. Random on a float is specified to return something underneath that float, right? So the argument is an exclusive bound. So it turns out that our random implementation had a bug. It used an inclusive bound, and quick hack, okay, just quickly implement a rejection sampler to throw out the if you are unlucky and you get the top one. Except on x86 32-bit, that still doesn't work because the equality comparison happened in the native 80-bit floating point mode that the chip provides. And so it wasn't rejected, but by the time the float was rounded down to the 64-bit double float IEEE, it rounded back up to the excluded value and was returned once again. And okay, fine, we should be more aware of the peculiarities of the hardware platforms that we're implementing on. But this is a bug that has existed in SBCL for 20 years. And even when we're alerted to it, we still can't get it right. And we're language implementers. So yeah, I mean, let's talk about doing something even more correct or even more fun. And absolutely, it could really be interesting, but it's hard. And I'm not saying cry me a river, but I am saying please be sympathetic to your poor hardworking implementers, and not too sarcastic when we get things hopelessly wrong.
Fair enough.
I think that to convince us to change something fundamentally to something fundamentally different on the implementation level requires incentive, like something currently is broken, but it will be much faster, or it will catch up to the world. Like we are changing 8-bit characters into Unicode. This is feature which is important for implementation in 2021. And right now, for instance, we are changing in ECL logs. We had all threading primitives implemented based on spin logs, and right now we are moving into native primitives of each platform because it is much faster and much safer, and hopefully less buggy. And this is a big change. And there is incentive. We want to be faster and more correct with threading.
Yeah, certainly a challenge. There's interest from Marco to ask, what was the hardest part about getting class right, correct, and did you get it thread safe too? For ABCL, the hardest part was finding someone to do it, which we got Rudy Schlau. I guess we got him from SBCL. He came over for 18 months and gave us code that made it work. It was really quite something. So single individual, well-defined problem, get it done. And he did it. And yeah, it's threaded to the extent that you can define threading semantics. Daniel?
I think that this was a question to Christian about Clasp.
No, class. What was the hardest part of getting class working efficiently and correctly in your implementation? And is it thread?
Okay, so right now in Common Lisp, we have inline accessors when possible with a few optimizations, but ECL implementation of silos is currently slow, and we want to implement fast generic dispatch proposed by Professor Robert Strand, and some groundwork has been put into the core for the last release. We have tagged classes, and we want to change the dispatching mechanism to take advantage of that. But it is not fast at the moment. I think that ECL is much slower than CCL, and that's BCL probably than of course than Allegro and Lisp works, but I haven't used them, so I don't have that on benchmarks.
Yes, Christian, Klaus.
Yeah, so for me, it was in two stages. One, getting it working at all on our C++ platform, and that I just kind of kept running the ECL class code over and over and over again until, and putting print statements everywhere until my code matched theirs. And then we implemented Professor Robert Strand's fast generic function method, and getting that to work as well was difficult because the sort of implementation touches a lot of things in class, but ultimately was a very good thing because it did improve performance quite a lot. So I can't really point to anything else. That's where it stopped.
And threading, was that a different challenge, or did that just kind of come along?
No, that was actually remarkably simple. But again, that's still evolving. We have good thread performance right now. Our problems are really in the memory management, and if we do a lot of allocations in different threads, it gets really slow. But we're looking at a new garbage collector to implement or incorporate MMTK into CLASP. But yeah, we did get multi-threaded performance quite quickly. And I think that just, again, because we borrowed so much code from ECL, there was a lot of thread correctness already baked in there.
Very good. So Kevin, you mentioned that CLASP was also the hardest part to get to ANSI, right? You want to say anything more about that?
Yeah, so our CLASP implementation was a fork of PCL in the 90s from Xerox. I think a lot of CLASP implementations probably are derived from that. So we ended up doing a lot of work on performance. I didn't do any of the work, so I can't speak to the actual details, but we did a lot of sort of single-threaded performance work. And then after we had the SMP version, the parallel threads, essentially, it took a long time to tweak the locks and the issues that arise when you have concurrently running code that heavily uses CLAS or MOP, and occasionally we find issues even to this day. I mean, albeit they're very, very obscure, and that most of them, I mean, there hasn't been a customer issue in probably more than a decade, but yeah, we tend to push the envelope a little bit more than our customers do with LegoGraph, because performance is essentially extremely important when you have billions or trillions of objects you're dealing with, and
you don't cheat and use defstruct. You actually use def class in the LegoGraph stuff.
So we don't use a lot of CLAS, but we use some CLAS. So I say that we cheat in some places and don't cheat in others.
Yeah.
So
I always do that too.
Yeah. So
okay,
that's basically it.
Thank you, Christoph.
Yeah. So class and thread safety, or CLOS and thread safety, if that's how you speak. So yeah, calling generic functions should be thread safe. So that means any caching that you're doing of effective methods needs to have, okay. So, that kind of thing, I don't want to say it works, but it mostly works. At least I don't know of any outstanding issues for the sort of calling standard generic functions. Things get interesting even before you get them up. And we have this is something that I am working on in my spare time. The issue of, well, what happens if one thread wants to modify a generic function while another thread is calling its function? Should it be allowed for something to remove a method while some other thread is calling that method? So the canonical case here is you've got a long-running server that is serving requests using generic functions, and you, the awesome developer, want to do a demo of how brilliant Common Lisp is, and you redefine a method in your implementation, and oh dear, bad luck, you get a no applicable method error, because the redefinition of the method is specified to remove the method and then add the new one. And so in that tiny bit of intervening time, if a request comes in, bad luck, you absolutely did have to call a method, a generic function that had no applicable method. Or do you? Well, maybe you could say that if there's nothing that could, in principle, observe the absence of that method, maybe we could elide all of that stuff and do an in-place replacement, and make much more of it atomic, or at least nearly atomic. I don't know whether it will be possible to make it actually atomic, but the thread safety at the lower layer doesn't necessarily imply that the things that are built on top of it are thread safe. Calling a generic function, fine, even with all the caching, but modifying that generic function, even through the standard interfaces, lots and lots of details that, PCL is, I think, 1982 or 1983. So, here we are nearly 40 years later and still discovering quirks that need to be thought about, and work needs to be done.
Yeah, I can think of two clever hacks. There's one, either you actually have it like software transactional memory somehow, but then you have to have a total ordering on all the thread execution, right? You could possibly do that at implementation level, or maybe you could just throw some meaningful conditions and have some restarts that would be helpful, right? I don't know. So the next question is, what has been the influence on the Common Lisp implementers from Scheme? So my influence on Scheme was reading the Little Schemer, the Sussman text. And it was my roommate was a computer science person, I was a physics person, and he had that text, and I had the Mac, so we got Scheme running on the thing for my freshman year. So that was my first exposure to it, and it's a phenomenal text. So Sussman was more important to me than the actual Scheme. Jack, Dan?
Well, from the implementation point of view, actually none. Sorry about that, but it was just a teeny bit fraction. I could be a schemer because when I was looking around Lisps, I really did like the idea, and I was looking for the actual dialect which will work for me. And I have learned that GNU operating system is declaring GUIX its official extension language. So I thought, okay, I will be a schemer, but no, I became Common Lisper. So,
Christian, you ever have exposure to Scheme?
Not much, no. I do watch the same, I forget what it's called, but the GNU Scheme implementation that's being
Guile?
put forward. Yeah, Guile is being put forward as the standard language. That's really interesting to me, and I look at a lot of the implementation details there, but not so much influencing Clasp.
Fair enough. Kevin?
Yeah, I haven't really spent a lot of time in the Scheme world. I mean, I respect what they're up to and so forth, but I just haven't really been influenced by it over the years. So.
Fair enough. Christoph?
I mean, on a personal level, I learned Scheme before I learned Common Lisp. And, maybe like you, I read the structure and interpretation of computer programs. I think that both the sort of scheme, I mean, maybe we have to call it the scheme family, like we call it Lisp, the Lisp family these days, because Racket is a very interesting place, and they are doing interesting things with giving users, empowering users to do interesting things with their language, and thinking about interoperability and tooling and that kind of thing, which is, I think, where more than at the language level, we can take inspiration.
Yeah, there actually was a question asking us about Racket. Does anyone have influence from Racket other than Christoph here? Julia? I had a postdoc friend in the past 10 years really lament. She went from Python to Julia, and they changed everything out from under her, and she went back to Python. So I felt really sorry for her. What else? Clojure. How much of us have used Clojure? No. Okay. Well, anybody have any closing statements or something they'd like to say, or this is a ANSI implementers panel of 5 implementers. We haven't spoken to each other before, really. Do you have anything to say to the other people on the panel, the other implementations?
I'll just say thanks for putting this on. When I first started the ANSI process at Franz, I remember going to one of the early meetings, and it was truly amazing to see so many Lispers in a room. I mean, I don't remember exactly where the first meeting was that I attended, but it was probably at like Park or somewhere, SRI, and there were literally like 100 people or more in the room, and it was pretty incredible. Gabriel and Moon and different people that I had heard about and knew through various mailing lists, and so it's kind of amazing to me that that was in what, 85-ish, and here it is 2021, and we're still doing this thing called Common Lisp. So it's pretty awesome.
Excellent. Anyone else?
Well, I want to thank you for wonderful implementations and keep up the good work.
Thank you.
Yeah, I'd just like to thank all the people who've been writing libraries over the years. We are using 81 quick list packages in our Can-Do computational chemistry thing to build up our sort of Jupyter Lab environment, and that's just a lot of people who put a lot of work into libraries that just work for us. It's been great.
Good. Christoph, closing remarks?
Well, what can I say other than it's been a lot of fun, and I hope it continues to be.
Likewise. So I'd like to thank you for participating in the panel, and let's get on with the ELS. Thank you very much, gentlemen.